Hey, Al.
Greetings, everyone. It is an absolute privilege to introduce our keynote speaker, Prashant Sethi. Now, let me tell you a little bit about Prashant. As an Intel Fellow and Chief Architect at the Microsoft Technology Center within Intel's Client Computing Group, Prashant has been at the forefront of technological evolution for over 2 decades. His leadership has shaped Intel's platform architecture, driving breakthrough advancements in computing experiences powered by Microsoft technologies. Now, today we have the rare opportunity to hear from someone who has not only shaped the present, but is actively defining the future of computing. Please join me in welcoming our keynote speaker, Prashant Sethi. His keynote is titled AI PC, achieving success at scale. Over to you, Prashant.
Thank you, Susan, for that great intro. Hello, everyone. Over the last few months, we have brought forth considerable capabilities with our AI PC products. So in this session, I hope to take everyone through their journey and our learnings along the way on achieving success at scale. We're not talking thousands of units, we're talking millions of units or hundreds of millions of units, getting to that milestone. And getting to that scale has taught us quite a few things, and I hope to share that journey with you in this session. So many of you may have heard about this AI continuum. There is this notion of training this really large model, such as ChatGPT, in the cloud, and then you deploy it for inference, and then you take the learnings from inference based on how your end users use it, um, send it back to the cloud, update your model, train it, and that loop continues. This is well known, and most people are familiar with it. Um, from a deployment perspective, though, this model, there's a few details behind the scenes. So if you're training a model, many times you're using a training framework where the original model is fine-tuned. And then to deploy it, it has to go through a series of transformations. For example, it may get quantized, or it may get bound to a runtime, and finally it all winds up in a nice package and then arrives at your deployment target, whether it be a CPU, GPU, NPU, or another kind of device. Now, what is inherent in this whole process is, yeah, this all happens behind the scenes, but where the rubber hits the road is when you actually start interacting with the end user. And in that respect, that's where the client platform becomes really, really critical, because ultimately the client is a connection of the end user to the AI, right? This is where all the work that has been done on the back end and building the product, your app, comes to fruition in terms of landing the experience where an end user can actually use it. So we talked a little bit about uh, experiences. And if you look at the overall AI PC landscape, there are user experiences and there are developer experiences. So what do I mean by that? Um, let's say you have a camera app and you have this eraser tool which can, take out somebody photobombing you in a picture. Well, that's a specific user experience. Uh, but in addition to that, with AIPC, we're not only just focused on experience, but building a set of broad development capabilities uh, that are available to developers to build your own magical experiences, to build new things beyond what is shipped in the platform. And that is unlike any other client device that's available, because the PC truly brings that, where you can use the same device for consumption and also for productivity and development for providing your experiences. Now, if you look at the prevalent PC market space, obviously Windows, is a big player here, and there has been a lot of focus between Intel and Microsoft in making sure that you get a great end user experience right out of the box with Windows. But then there are also these broader frameworks, because not everybody is going to want to be locked in a particular ecosystem. Uh, and even for that, we want a great experience on our AI PC, where you will see even cross-platform frameworks such as Microsoft's Onyx or Intel's OpenVINO are available across a range of platforms. So this product, when we were building it, is very focused on making sure that we provide the broadest and deepest end user experience and developer capabilities across the entire software stack. Well, what does that software stack look like? Many of you may have seen this picture in different forms. At the lowest level is the hardware. In our platform, for example, there's a CPU, GPU, and an NPU. Layering on the top of that is drivers that make the underlying hardware available to the higher level layers. Then there may be foundational libraries that provide optimizations or functionality building on top of the hardware and making use of these drivers and instruction set capabilities. Uh, and layered on top of that, maybe some kind of a runtime, right? If you're a web developer, you may have access to some of these capabilities through a framework such as WebNN or WebGPU. If you're providing a native app, it may be packaged with something like Microsoft's Onyx runtime, and ultimately it's the application that lands um, on the platform, which the end user can use. So then on the hardware side, we're actually bringing the Intel Core Ultra 200V series processors with unmatched capabilities to the client platform, spread across the CPU, GPU, and NPU, along with the various vector extensions and matrix extensions. We have up to 120 TOPS. That's a lot of compute power that is available on the platform. So as an example, uh, in today's world, we can take what used to be a 12 billion parameter model that you could only run on a workstation on a high-end server class machine. You can now run something like a Flux model for image generation, which is a 12 billion parameter model on your laptop, and an end user could go deploy some capability like this. Now, I briefly talked about the software stack, the hardware capabilities we are bringing through, and the capabilities that are possible on our platforms. And in addition to that, we're there's considerable industry leadership from Intel and its partners. For example, we're heavily involved with the Onyx standards leadership. We're on the PyTorch governing board and chair a bunch of W3C bodies, bringing web APIs such as WebNN to this platform. So this is really, really a great story around hardware, software, core design, moving all parts of the ecosystem forward so we can land an awesome experience that is available to the end user. So now that we've covered the fundamentals of some of the ingredients, I want to focus on an example of where we bring a solution to the platform that's available out of the box to the end user. And you might have heard press about an entity called the Copilot Plus PC. So together with Microsoft, we brought this capability onto our Core Ultra 200V series processors. There are a number of experiences that have been enabled with Windows 11 Insider Preview builds as of late last year, early this year, on these Copilot Plus PCs that are available right out of the box, assuming you're running, some of these the right build. So what are some of these experiences I've seen by the end user? So from an end user's perspective, there's a few broad categories, right? You're likely going to look at some kind of an image recognition, image enhancement type of model. There will be some element of text interaction, text generation, whether that's optical character recognition or live caption. And then there are some elements of generative AI. So for example, let's say you're working on a presentation and you want to create some fancy images, or you want to retouch up your photos, or do something personal, or personalize your content. So that's where some of these generative models comes in. And all of this ties together really, really well in terms of a seamless end user uh, with context-sensitive menus. So basically, you can be anywhere in your workflow. Click the right context menu. Click your mouse and be able to go do these things in a very seamless manner. And this is a turnkey experience. It sounds simple to get to, but it has really taken us quite a bit of effort to get here. So let's go back to our workflow that we briefly touched on earlier, where we say, okay, what does it take to go from models to deployment? In a very simple manner, you know, this is a chart that we had on earlier. We start with some kind of a training framework. Uh, we run it through some kind of a model optimizer, quantizer, which spits out, some intermediate code. We package it with an inference runtime, and we deploy the target on the PC. All right. Now, I mean, that's a very simple form of the workflow. The reality is quite a bit different in terms of getting to a scale where this is available to end users in a very, very seamless manner. So here is what really happens behind the scenes. On the left side is the basic software stack that everybody has seen in various places, basic software architecture diagram. But in reality, the workflow is more along, the thing on the right, where you have an idea for an application and say, okay, I'm going to build an application. Uh, Many people aren't going to go develop their own models from scratch. They're going to go to a model zoo of some type or academia and pick up something that's prevalent and readily available. So that model gets ingested into the workflow. And then people say, okay, let me go run it, right? Maybe you run it initially in PyTorch, eager mode, and say, okay, this seems to do the things I want to go do. But that's not how people are going to go deploy it. You're not going to tell your user, hey, go download these set of toolkits and other things. So that model has to be ingested in your application, which means, you build a prototype, run that thing, and it's not just only on the application developer. That goes hand in glove with feature development on our platform. For example, you're going to, with the platforms, and we provide a really, really good set of underlying features. There will be a driver, a firmware runtime. There will be some kind of a compiler to target these accelerators or the NPU or the GPU, and there'll be a framework. Uh, and all of that has to be mated together with the model that you ingest and the features that are provided by the platform to build an application. And once the developer has proven all of that out, uh, you end up in what I call the integration phase. Now the application, the model, everything is usable. Hopefully, as a point and click app that people can just go download and launch, or a complete experience that's deployed on the web. And that's when the fun starts, right? I mean, you start looking at uh, the model and the application, and then you start looking at performance, right? How long does it take for the user to get an answer from the time you put in a query? Does it affect the battery life, right? I mean, it's no good if you can go do some, really high performance throughput type of computing, but it has energy efficiency issues. So we've got to do, in order to do it at scale, we have to do it in an energy efficient manner. Then there are basic things like, oh, did the app crash, right? Or did I protect the user's data? Or did somebody try to run a security attack on it? So we learn things as we go, through this platform integration and validation, and running the app ourselves, find bugs, and then this feeds back into the integration and model development process as we tweak. And that's the continuum, in addition to the continuum that we talked about, which is a hybrid loop. Within the PC itself, there is this continuum of getting your application, evolving it, building the next generation and going and trying to achieve scale with it. And when we attempted this, there were a lot of lessons from deployment that are not typical in other AI scenarios. So if you look at, for example, in a high performance computing scenario, or a training infrastructure running on a bunch of GPUs in a cloud, that's fundamentally a different approach than something that has to be just really, really crazy simple for an end user to just go download and run, right? That's where the rubber hits the road. Uh, not in an embedded scenario, right, where you have complete control of the environment, or in a data center environment where there's a ton of experts ready to support and revise your models, right? This is the wild, wild west. And when we deployed this, we learned quite a few lessons, which I'm hoping people embark on their AI journey of achieving success at scale. These lessons are useful. So the first one, responsiveness matters, right? People want instant gratification, and we talk about inference latencies, uh, but there's also this notion of this first ever inference latency. Typically, if you look at any real scenario, there's not a single model. There's multiple models chained, and potentially these can take many minutes to compile. Right. So if you deploy an app and it's landing on a platform and it has to be targeted at the NPU, GPU, and CPU, there's some bring up time involved. Think about the user experience that has to be in place so that the user doesn't observe any delay, right? It's very frustrating when you fire up an app and you put in a query and it says, wait a few minutes, come back, or go grab some coffee. So we have to be very, very cognizant about providing great user experience on responsiveness. Now, responsiveness doesn't necessarily mean uh, providing the experience for the user on the model itself. It's responsiveness for the whole computer, right? Now, the PC is not a single purpose appliance. And in some cases, people talk about benchmarks. Yeah, those are important, but maybe there are some unique scenarios where you're searching through millions of photos or thousands of photos for a particular object where throughput might be important. But for the most part, this is not a throughput driven appliance. You're not measuring how many inferences per second you can do. This is more about having a balanced platform which balances your compute and memory resources uh, to provide the lowest latency experience to the end user. The other element that kicks in is when we think about these kind of deployment lessons, is serviceability and compatibility. It's very, very, very easy to deploy a point product, right? That doesn't have to have an upgrade path. You say, okay, here's an embedded device, deploy a model to it. There's a custom OS, custom thing. We can make those kind of things run really, really fast, and you deploy it in a scenario where it does its job and does that job forever. But that's not what our customers do, right? If you look at it, the users expect an installable app, not a model plus framework plus compilers plus tools and scripts. And if there's an update to the model or an update to the framework or the compiler, people aren't going to download individual components and go do that, right? Now their expectation is they get an app, it works, and they get a new app. Maybe that, and the expectation is there's no reason to believe that that app works. Or if you get multiple apps, they should all work together, right? Uh, and where it gets really complicated, it's really, really, easy to build something for the first generation product. For us, this is not our first generation product. I mean, this is the one that, we've brought a whole bunch of capabilities together, but it took a lot of learning along the way. And what we found out, and this is what Intel is great at, right? Is there's a reasonable expectation that whatever workloads you have from today run on next gen hardware with similar or better performance without recompile, right? So you can make an investment in hardware and software today and expect that investment to give benefits over the next several years, and so you can reap the benefits, right? This is not a point product. We're looking at hundreds of millions of units, and you will see a continuum of Intel products that have a history of supporting this back and forth across generations, and so this is something that is important to the end user and worth thinking about. um, and finally, the kind of workloads we're running require us to respect confidentiality and privacy of the end user. I mean, this is in general very, very good practice, right? We want to make sure that we have a trustworthy, robust platform for our end users, and in order for us to work with the user on AI technologies, we're going to be operating with their data, right? We're going to personalize the experience to the end user. And it's important to not breach that trust. So and that presents a dichotomy, right? AI by its very nature today is fast moving. We live on the bleeding edge, where as if you look at security and robustness, people say, oh no, we've got to slow down, test everything, make sure there are no gaps. Otherwise it can lead to a pretty poor experience for the end user, where you might get to market faster, but you may not be able to scale like you want to if you end up with a security or robustness issue. So what does that mean to us in terms of developing experiences for this AI PC? What are some of the actionable items that we can do in order to plan for scale? So these are just some examples. I'm sure people will discover more as they play with the the infrastructure. So first one is responsiveness. Um, Normally people think of the AI workflow as a monolithic continuum workflow, but for deployment, you might want to think about repartitioning the problem, right? Uh, if we look at a reasonable platform going forward, and for example on Windows, Microsoft has published App SDK and APIs for that. There's some capabilities that are going to be built into the platform, right? Just as for example today we have web rendering engines built onto the platform. You're likely to have some kind of an image recognition model, a text generation model, a Gen AI model, text generation model. So you want to really think about is, from an application perspective, is it best to use a pre-packaged inbox infrastructure that is tested and proven, across our software stacks and the operating system, or do you want to really roll your own, right? I mean, there may be advantages to rolling your own, but again, there is this responsiveness element which comes in, because once you roll your own, you have to worry about servicing, deploying it, and the inference latency. The other part of this thing is, how much of this work do you do offline in terms of application development versus online in real time, right? Now, again, if you're in academia, you can afford to go build this workflow as an end user. But maybe there's some amount of offline work that needs to be done for an application. Say, for example, figure out, okay, what are the good data types? How do you want to quantize the model? What kind of caches or responsiveness or working set choices we make, and that may require a repartitioning of the workflow in a manner different than what you receive from the cloud with the various frameworks in place. And then, again, in terms of responsiveness, normally when you'd be benchmarking, you'd be looking for a throughput benchmark and maximize the number of threads and working set sizes. But that may not be the right answer there. I mean, if things have good locality, do you really need to keep the whole model and everything, the whole workload in memory, or can we, page it in and out without affecting responsiveness? Moving on to serviceability and compatibility, again, think about optimizations, especially if you're providing, a set of libraries that get used over and over again, where the application must have a path to deployment on future hardware without regression, right? In some cases, the hardware is nice, right? Like, for example, if you look at our CPUs, we nearly always give you a monotonically set of increasing capabilities with support for backwards compatibility, and the hardware just takes care of it. And that's what Intel's really good at. But as you look at your problem and try to deploy across the horizontal ecosystem, you have to think about, okay, is the experience available everywhere, right? Maybe repartition the problem statement, look at fallback paths, because people are going to expect that once they purchase an application, that's available through the gamut of the PC ecosystem, rather than a particular point product. And as an example, we do ship a fair amount of hardware-specific code that's optimized for our hardware in terms of drivers and firmware. So There is merit in reusing that, because once we update the hardware, we'll update all of this collateral that goes with it, in attempting to go play with it. Now, this is not a one-size-fits-all. For example, if there's a subscription-based application, there may be additional deployment flexibilities versus a point application. But something to think about is not only how do you get your, app in front of the end users, but how do we scale the experience? And finally, last but not the least, is confidentiality and privacy, right? I mean, this is a very, very, very evolving, continuously evolving area, where there are new attack vectors and new solutions every day. And my recommendation here is use the existing capabilities that the existing platform provides to the max. We have virtualization capabilities, for example, that are used by virtualization-based security. There's already APIs and capabilities provided by the platform to protect your data, whether it's at rest, in transit, or during compute. And be aware that deploying in a secure environment may pose some additional constraints on your platform, right? So, for example, it's very, very easy to get to a native bare metal platform, but once you are in a containerized environment, or in a secure environment where somebody says, okay, well, I'm going to deploy things like no execute and limit self or cross modifying code to avoid buffer or code injection attacks. That's a different environment than what you might be used to. You're running in a normal bare metal scenario. So think about reusing the platform capabilities that Intel platforms already provide. I mean, there's a rich history here over the last decade or so in terms of serviceability, compatibility, confidentiality, privacy. It's not just about the fancy AI model, right? It's about getting to scale to offer a robust and responsive experience to the end user. And finally, I mean, you don't really get to have success with it unless you test and validate at scale. So, this is where, there's the good news is we have a great set of tools available for everyone. So if you look at our AI PC umbrella, there's a URL available, which is a great starting point on acquiring, for example, a dev kit. This is not unique hardware. This hardware is available at scale from many of our OEMs. And there is a lot of collateral that's posted on this URL so that you can get started as a developer with your own applications and have that experience lit up and try it out in real life. So hopefully, this is a good flavor of things, that need to be considered for achieving success at scale. And with that, I'm going to encourage folks to, make use of these resources on our AI PC platform and open it up for Q&A if there's any.
Hey, Prashant, I've posted that it's time for people to go ahead and post their questions. So we will give them a minute to think. And let me start off though, Prashant, by saying thank you. And I really can hear your extensive development experience come through in your lessons learned. It sounds like you may have experienced some of those pain points yourself in trying to go from that developer workflow of an idea to creating an actual deployed app. And let's make it run at scale while you're at it. And you shared lessons on responsiveness, serviceability, and confidentiality and privacy. Can you talk a little bit more about what do you mean by serviceability? And what is unique about client serviceability in particular?
Yeah, so but what I mean by serviceability is that if you this is a very dynamic environment, right? You get operating system updates, you may get driver updates, and we have to have infrastructure in place and mechanisms in place so that not only does the user get the experience out of the box, but it continues to run as expected for the life of the platform, right? And that includes things like, okay, consider if you deploy a model, right, and something goes wrong with it, how are you going to deploy an update? Is that something that gets pushed through the operating system channel, or is that something that gets pushed through a store app, or do we, advertise to the user to go, pull it? And in our opinion, the best use of this is to provide an experience that's turnkey, that requires the user to go through as few steps as possible. And this is where, between Intel and Microsoft, we're looking at bringing a great set of capabilities to the x86 ecosystem, which is well known for handling, these kinds of turnkey experiences, um, and many of these are available in box. So you don't have to go through, 6 different places to get your initial experience up and running, and you shouldn't have to go to 6 different places to get, uh, you know, uh, for an update to that experience, right? We have very, very good track records with our OEM and our software partners in terms of providing these turnkey experiences, and I'm encouraging the AI developers to go use that.
Great, thank you. Thank you for responding to that. I have a few more questions for you. We have some time. What do you think is unique about client AI solutions versus, let's say, data center or IoT edge? Can you talk a little bit about that?
Yeah, so client is a little bit more of the wild west versus a data center or an IoT example, right? So if you look at an IoT example, let's start with that. You can build an application, you can predict how much compute and memory do you have, you build a solution, you deploy it. Yeah, you might have to go update it, but by and large, it's a known environment, right? You're not thinking about, okay, I deployed one AI solution on a given piece of hardware. Let's say a smart shelf or a home monitoring system. Nobody's going to say, oh, well, I have a home monitoring system and I'm going to go run image generation on it, right? It's going to run image recognition, something that you talked about, but nobody's going to run, word processing or content creation or, other things on it. In that constrained environment, significantly reduces your validation matrix, right? You don't have to self-host that. Similarly, on the data center, while you do have to worry about security and some of the other parameters, again, it's a very controlled environment in the sense that if you're in the data center, you're not going to expect users who have no familiarity with the infrastructure to be installing and uninstalling, applications. If it's a backend, typically there's an IT professional involved, and and they're much more savvy with that environment. On the client space, none of all of these assumptions go out of the window, right? You have the Wild West, you can install anything and everything, and we actually promise that experience. And that is where we require a lot of thoughtfulness along the vectors I called, in terms of self-hosting, integration, validation, and also coexistence with other scenarios. So it's really the uncontrolled, unmanaged nature of the environment that makes it unique versus data center or IoT.
Thank you for that clarification, Prashant. So a question has come in about, does the AI PC support Windows subsystem Linux?
Yes, it's a very good question. And if you look at the infrastructure, the goal is to surface all our capabilities to all of the subsystems that run on the platform. right? So in the past, I know in the past we've demonstrated over Microsoft Build some models that were working, in the Windows subsystem for Linux. And Microsoft certainly has done a lot of work in terms of, for example, making GPU capabilities available on the WSL side of things. So from an Intel perspective, our goal is to enable the operating system capabilities to the extent that's supported by the OS across all of the various subsystems, whether they are running native Windows through the web platform or through any other environment that may be resident on their platform. Now, having said that, some of these may be in development. So, for example, you may have heard about WebNN and how that experience has been getting deployed, and you may have seen some of those demos at prior conferences, and that is an experience very much in development. So this is a rapidly evolving field, and as these capabilities come to market, you will see these get lit up progressively over time. But the good news is that the hardware is very, very capable. So you can safely make that investment in an AI PC today and continue to reap its benefits over the next few years.
Great. So we are going to take one more question. And that question is, what are the implications and recommendations for Intel AI developers on how to deploy initiatives such as OpenVINO, OneAPI, etc.?
Yeah, so that's a very good question. And there are, at any given time, there are a bunch of frameworks that are available that people can go stitch together. And it's an interesting choice, right? And there may be no one size fits all answer at the moment. For example, right, if you're targeting solely the Windows ecosystem, there's a great set of tools that are available on Windows through Microsoft. They have an application SDK. They're on a path to provide various models. But that that initial picture I showed, that takes you in the the top left of the corner box. But some people with their applications may have wider implications, right? For example, some of them may say, okay, I want to deploy to the web, right? And then in that case, it's a browser-based ecosystem. Or many of them say, oh, this is a model that we want some degree of portability, and OpenVINO and Onyx runtime provide that infrastructure. So what I would encourage folks to go do is to really identify the set of requirements and then go with that, right? There's not going to be a right or a wrong answer there. It depends on the what market segment you're targeting and what servicing and deployment channels are available to you.
Thank you, Prashant, for that. Okay, so we are finished up with the Q&A. Thank you so much, Prashant, for this amazingly informative keynote and for sharing your extensive development experience with us. Now, audience, please join us for our next session, which is a workshop where Shri will be introducing our speaker, Yuri Winch-Ackerman, who will be conducting a workshop on fundamentals of LLM fine-tuning techniques. I will see you there. Thanks again, Prashant. It was great to have you with us today.
Thank you.